Oh, hey guys. This is for those of you who, one, were absent in class and didn't get to get the information for exponential functions. So we have moved on, today's the 27th, to exponential functions. So we're taking this equation right here, y equals b to the x power, and x is now our variable, which is an exponent. X has been our variable. He's just an exponent now. He's moved his location. These notes start off with the asymptote, but he's not really that important, but it's the definition that you might need for a vocab quiz. So let's go ahead and jot that down. An asymptote is a line that a curve approaches as the curve heads towards the x-axis. The curve never touches the asymptote, but it'll get very close to it. Here we have y equals b to the x power. Typically there's an a, but a equals 1 when it is not visible. And you'll see a later on this page. So the b represents the base, b is for base, of your exponential function. So it's at the base or the bottom of your exponent. The base is always a number and the exponent is always a variable. So there's my exponent and my variable is my independent. X is typically time in the real world situations. So when your base is larger than 1, the exponential graph grows. So the graph increases from left to right. This is called growth. So in order for me to remember that, I always like to write my name on the line. So I'll write A-N-G-E-L, and my name is going upward. On this one, my name is going downward. So this is the opposite of growth, which is decay. And this is where the graph decreases from left to right. L-E-F-T-R-I-G-H-T. Okay. And then down here, here's the A that I was telling you about. So the A is my initial value, or my y-intercept. Okay, it's where my graph starts, where it starts either decreasing or increasing. My B is my growth or my decay rate. So typically it's a percentage. It is growth if B is greater than 1, and it is decay if B is between 0 and 1. So it's typically a decimal here when it's between 0 and 1. It can be a decimal greater than 1 as well, but this is where we really need to pay attention to its value in relation to the number 1. My domain is typically negative infinity to positive infinity, which is all real numbers. And my range is typically y is greater than 0, but sometimes y might be less than 0 on an IXL lesson. I don't think you're going to be tested on this, but you still need to know it for the sake of IXL. And your intercept is 0, a. So keep in mind that growth functions look like f of x equals 12 to the x power, or g of x equals 9 to the x power, or q of x equals 5/4 to the x power. This is a fraction, but this fraction is greater than 1. Decay functions are h of x equals 1/2 to the x power. R of x equals 1/3 to the x power. And w of x equals 0.7 to the x power. All of these values here at your base of your exponent are less than 1. Okay? So this is my b is between 0 and 1, And here my b is greater than 1. Okay, so this is the b, and this is the b over here. And typically, these will be shooting up, and these will be shooting down. Okay? All right, so now let's look at some questions. So write the exponential function equation. So that's y equals a parentheses b to the x power. The asymptote, always, always, always remember that the asymptote is y equals 0. Okay, this is only for algebra 1. Only algebra 1. Okay, in algebra 2, your asymptote can change, but for our sake and our purposes, please remember that the y equals 0 is my only asymptote that I need to remember for this. The y-intercept is typically 1. Let me double check my notes to make sure I'm not telling you a lie. It's always a. And the best way to find it out is to graph it on Desmos. So it's not 1. Graph and use Desmos. That way you can visualize where the y-intercept is. So for this one, it says graph each function, find the y-intercept, the asymptote, and state the domain. So I'm going to go to Desmos because I'm going to need it. Okay, my first graph was 0.3 to the x power, and in order to hit that exponent, I'm just holding down the shift button and then the 6, that little caret thing. And then here's my graph, and when I look for points, I'm going to hit edit list, which is the settings button or the gear, and then here are my points. So I've got 0 and 1. And 1 and 0.3 and 2 and 0.9, and I can look at these and kind of see what these are as fractions. What I would do is I would go to the next line on Desmos and I'll type in 0.3, and then I would raise it to the power myself, so 0.3 to the negative first power, and then I hit this fraction button over here and then it turns into a fraction for me. So this is 10/3, so this is 0.1. 1 and 3/10, 2 and 900ths, and so on. So when I come to graph it, zero and 1, this is a 2, so I'd come in between that, and then I would do -1 and 3.33. So -1 and 3.33 is about right here. And then -2 is 11.11, so this is 2, 4, 6, 8, 10, 11. So come over here, and then, wait, 2, 4, 6, 8, 10, and then halfway through. About right there. Excuse me. And then my asymptote is just going to be as it approaches the x-axis. Boom. Bam. So my y-intercept is 0, 1. My asymptote is y equals 0. My domain is all real numbers. My range is everything above the y-axis, so y is greater than 0 because it doesn't even let me go below. And then I'm going to highlight my asymptote so you can see it. Boom, right there. It's going to be right here for all of them if I'm not mistaken. But let's double check and see. Okay, let's calculate the next one. Y equals 3 to the x power plus 1. Oh, it shifted up. So now my asymptote is y equals 1. So it's right, this is a 2, so it's going to be in between here. And then I need to get my points, 0, 2, 1, and 4. So come plot them. 0, 2, run 1, jump 4. What would 2 be? 2 and 10. So run 2, jump 10. 2, 4, 6, 8, 10 right here. So then it will increase like so. So my asymptote here is y equals 1. Now, you're not going to see a whole lot of these where your asymptote does not equal 0. So this is just taking it a notch above. Okay, this is the APA version. So my y-intercept is 0, 2. My asymptote is y equals 1. My domain is all real numbers. And my range is y is greater than 1, because remember, it touches, or it approaches the asymptote, but it does not touch it. All right, so I've got something similar here, and this is plus 3, so it's probably going to be an asymptote of 3. And then this is 1/3 to the x power, to the x power. There we go. Let's get rid of those old points, and it looks like my asymptote is at 3 here. And let's find some new points. -1 and 6, 0 and 4, and -2 and 12. All right, so -2, this is -1, so -2 and 12. 2, 4, 6, 8, 10, 12. And then my asymptote is 0, 4. 0, 4, and -1 and 6. -1, 4, 6. And then my asymptote is right here, so it's going to go like this. Okay, and this is y equals 3. So looking at these down here, these are where we just identify our y-intercepts. We're going to skip the asymptotes. We're just going to look at the y-intercepts. So here my y-intercept is 2. Here my y-intercept is 1. Here my y-intercept is -2. Here my y-intercept is 1. Here my y-intercept is also 1. Again, you won't see very many of these as well. All right, let's jump into IXL and let's look at BYF. Now, you have a quiz on IXL that is graded, but BYF gets to tell you, it gives you an idea or a practice of what you're going to see on your quiz. So let's go to BYF. So here we are. So we have 3 to the x power. Typically, anything to the 0 power is going to be 1. So I'm going to look for the point 0, 1. That's right here. That's right here. That's right here. Oh, everybody's got 0, 1. So now I'm also going to look for other points. If I go to Desmos and I type 3 to the x power table, 0, 1, and 1 and 3. So I need to find a table or a graph that has 0, 1, and 1 and 3. This is run 1, jump 2. This is DK, so this is going to be a fraction. Probably this one because it's going down and this fraction is less than 1. But 1 and 3 is going to be it right here. So I'm going to take this and drag it down here. Now, DK, this 1/3 right here, this is going down. So I'm going to place that one there because that's the only one going down. 2 to the x power. So if I plug in 2 to the first power, I should get 2, right? So 2 to the first power, I get 2 here. And then by process of elimination, I've matched them all. Let's see if I got them right. I did. Okay, so let's look here. These 2 are decreasing, so I need to be mindful that they're going to be going down. So these 2 are going down. And then I can look at the negative first power. So the negative first power here ends up at a 3, which would be 1/3. And the negative first power over here ends up at a 4 because you're looking for the reciprocal. So those are there. And then 4 to the x power is where you run 1 and jump 4. This is run 1, jump 3 here. So you're going to drag the 3 and then drag the 4. So this is simply just matching your equations there. All right, keep at it. Get this to about an 80%. This is not graded. Your IXL quiz is what's graded. You're going to be doing roughly the same things there. Good luck.